purpose of this video is to summarize what we have learned so far in the loadings, alright, under the loadings. These loadings all started out from video 2.2 all the way to 2.7. Okay, so it's all these videos. Okay, so these two videos talk about the longitudinal one, alright, 2.2 and 2.2.1. Okay, it talks about the, if you just a recap, we have a matrix over here. In commercial name, we call the matrix, we call it the resin. Okay, and we put in the fibers. Alright, we put in the long aligned fibers. Okay, if you don't understand anything, you can just head back to other videos, the old videos, and watch it up. Okay, yeah. Anyway, or in other words, long aligned fiber, continuous fiber is, I'll just explain here anyway. So it's long aligned because they're all aligned. Continuous because it's continuous fiber. That's just the name. So having this condition, if you apply a loading in this direction, this is considered a one direction. Alright, and the stiffness or the Young modulus, or the stiffness is a bit related to the Young modulus, so we can call this E1, the Young modulus 1 in the one direction, and we will have a transverse in the E2 direction. Alright, this is the two direction. Okay, and nonetheless we have a three direction, E3. Okay, and for E1, alright, for the longitudinal direction is these two videos. For the transverse direction is this video. Okay, and we will have a shearing between this plane, this 1 and 2 plane, which it kind of at first it was like this, if I were to put this plane over here. Alright, and over here it will shear. Okay, or in other words, if I were to draw it more clearly over here, this thing will be sheared. Alright, you will be shearing in this manner. Alright, so this block over here will be sheared into this shape right here. Okay, as you can see, it's being sheared. Alright, and therefore this is just the three things: the longitudinal, the transverse, and the shearing. Okay, which the shearing is in the last video, or the previous video, or V2.7, and in between there will be understandings that I'm going to go through. So this is somewhat like a summary now, and also to give you the introduce you with the concept of the Poisson ratio, and later on we'll talk about the Poisson ratio. Anyway, so the longitudinal one is isostrain. First thing you need to memorize, and then you have to understand the fiber efficiency ratio. Is factor, sorry, which is over here. You see, so this is the fiber efficiency factor based on all this. Alright, I hope that you understand. This is page 46. You can go and watch, or you can watch the videos that I've mentioned just now. Alright, and they're in the one direction. Alright, which is in the one direction. This E1, E2 is in the two direction. Okay, so this is in the one direction. Okay, and next is that transverse loading. For transverse loading, there is other names like Rose estimate and Rose model. For longitudinal, they are named as axial loading or Vogt model. Okay, so transverse loading, iso stress, assumed loading area are the same. So meaning that the area, alright, explain properly. Iso strain means that all strain in the fiber is equals to the strain in the matrix equals to the strain of the composite. Iso stress means that the stress is equals to fiber equals to the stress in the matrix and the composite. Alright, assume that the loading area are the same, states that the area where you pull for over here, this is your matrix. If you were to pull, or this is your fibers also, if you were to pull, you are pulling in this two direction, right? So this is the area that I'm talking about, and I'm assuming that this area is the same for all other stuff. So over here, this is the area, and this area is the same as this area also. I was assuming that. Okay, and this is why AF is equals to AM is equals to AC also. Okay, so then it's in the two direction, as we have said, is pulling in this direction. Okay, and it's like your XYZ lah. Alright, it's not saying that you pull in two direction like that. It's talking about in the one is X, in the two is Y, but we don't call it X and Y, we call it one and two direction. Okay, hopefully this is clear. And then shear loading is in the 1-2 direction, that's all. Okay, however, in this two direction, longitudinal and transverse, there is some rule of mixture model, and there is some assumptions that you have to take note and learn, and therefore these assumptions are being reflected, alright, in these three videos. Okay, and these assumptions would help you to just understand all this stuff, especially the graph over here. you want to memorize this graph, alright, and you also want to memorize these equations also, the upper limit and the lower limit, nonetheless for this one, alright. And this one comes from your longitudinal equation, where I think you also need to have another k efficiency factor over here. Yeah, and you also need to know the modified series model as compared to the theoretical one. Theoretical is theoretical, modified series model is a model for a more realistic in the real world compared. Alright, and then after which, alright, so these are the things that I just said. Alright, and with a more bigger picture now, alright, for the one that we have said all along, we are always assuming that the Poisson ratio are the same true for all materials. So for all these materials, the Poisson ratio are the same, and with this assumption, then we go into different understandings of all of them. Alright, so now we are actually coming up into the Poisson ratio and see what if the Poisson ratio change. Alright, if the Poisson ratio change, alright, then what will it so-called affect our stuff. Alright, and therefore this give you a brief understanding of what we're gonna do next in the next video for Poisson ratio. Alright, and after that, and applications, and we are done for this lesson. See you there.